In our incredibly connected world, well, we're all basically swimming in this deluge of information, right?
Mm.
Especially when it comes to something as complex and, frankly, fast-moving as AI.
Mm-hmm. It's a lot.
It really is. It's easy to feel lost, kind of overwhelmed by just the sheer volume of news, research, opinions flying around.
Yeah, absolutely.
And that's precisely where the deep dive comes in. Our mission, really, is to cut through all that noise, distill the most important insights, and give you, our listener, a real shortcut to being truly well-informed.
A much-needed shortcut.
Today, we're diving into a subject that's not just technically fascinating, but one that profoundly impacts our daily lives right now: ethical AI. And specifically, the critical challenge of algorithmic bias.
Right.
It's not some abstract future problem for sci-fi movies. It's here, it's now, and it's subtly shaping things like, how we get loans or even who gets a job interview.
It's incredibly pervasive.
So the big question we're exploring today is, how can we make sure these powerful AI systems genuinely serve humanity and maybe even build a more equitable future instead of, accidentally making existing societal harms even worse?
That's the perfect framing because, like you said, ethical AI has really moved beyond just abstract speculation.
Right.
It's transformed into this critical multidisciplinary field of practice. It directly addresses tangible and, frankly, immediate risks and benefits.
Okay.
So our goal today is to help you understand not just what ethical AI involves, but really why embracing it is so fundamentally important right now for anyone building AI, deploying it, or even just interacting with it day to day.
So it's about fairness, transparency, accountability, all that.
Exactly. Navigating that complex spectrum to build systems that, truly benefit all of us.
So let's really dig into this. When we talk about ethical AI, what does that really mean in practice? Is it just like following a checklist of rules? Or is there something deeper going on?
Oh, it's definitely more than just a checklist. At its core, ethical AI is about guiding moral conduct through the entire life cycle of these technologies.
The whole life cycle.
Yeah, from that initial spark of an idea through development, deployment, and even its ongoing use. It's really about ensuring these incredibly powerful tools actually serve humanity for the better and align with our core values. It's meant to be holistic.
Okay, holistic.
And this isn't just some feel-good add-on anymore or, a compliance burden to tick off at the end.
Right.
There's this really crucial concept called shift left.
Shift left. Heard that term.
Yeah, and what's truly revolutionary about shift left isn't just avoiding legal trouble. It's really a fundamental re-engineering of how we build AI.
Okay, how so?
It means ethical considerations are no longer just a peripheral concern or that final compliance check you do right before launch.
Mm-hmm.
Instead, they're now a central part of the design and implementation, integrated right from the very beginning.
From day one.
Exactly. Think of it like weaving ethics into the very DNA of the system. This makes ethical design integral to creating systems that are genuinely robust, reliable, and trustworthy. It's kind of the secret sauce for building inherently more innovative AI, not just, nicer AI.
That shift left idea, that's really powerful. And it seems like it's echoed in these global discussions leading to what people are calling the core principles of trustworthy AI.
Absolutely. There's a growing consensus.
Yeah, even if the formal laws are still catching up everywhere, there seems to be strong agreement on these foundational ideas. We could probably list a dozen, but let's maybe touch on a few key ones.
Sounds good.
Okay, first, fairness and non-discrimination. This seems pretty fundamental, preventing AI from creating or amplifying existing systemic biases, making sure everyone's treated equitably.
Crucial.
Then there's transparency and explainability, often called XAI. This means AI decisions need to be understandable, not just what happened, but how data was used and why a certain prediction came out.
Yep. Opening the black box. Exactly. And third, accountability and responsibility. So, organizations making and using AI are accountable, and ultimately, the ethical buck stops with a human, right? Not the algorithm itself.
Always a human.
And finally, human centricity and oversight. This idea that AI should help us augment our capabilities, not replace human judgment. That human-in-the-loop model we keep hearing about.
Yeah, essential for critical tasks.
Does one of those maybe resonate more strongly with the immediate challenges we're seeing right now?
Well, they're all critical, truly. But if we connect this back to the societal stakes you mentioned, the failure to embed fairness and non-discrimination, that leads to incredibly tangible, significant harm.
Right, real-world impact.
We've seen some stark examples. AI-driven insurance systems generating discriminatory premium quotes for minority individuals. It happens.
Wow.
Or healthcare allocation algorithms that, because of biased proxies in the data, end up denying care to the sickest patients, basically deciding who gets help.
That's terrifying. It is. And even in criminal justice, tools producing racially biased predictions of recidivism, which can massively impact people's freedom.
Yeah.
And each of these instances, it doesn't just cause direct harm, it profoundly erodes public trust in these systems and the companies deploying them.
Which has consequences.
Absolutely. It can lead to severe reputational damage, regulatory fines, financial losses. But conversely, ethical leadership in AI isn't a barrier to innovation. It's actually foundational to achieving innovation in a genuine, sustainable way. It's really a prerequisite for long-term success now.
That brings us right to algorithmic bias itself, which, as you've just highlighted, isn't just, a few isolated bugs or errors.
Not at all.
It's systemic. And fundamentally, it sounds like a human problem where our own societal prejudices or maybe just flawed assumptions get mirrored and often amplified by these systems.
That's a great way to put it. Amplified is key.
So where exactly does this bias creep in? How does it get baked into the system?
Well, it's pretty pervasive. It can infiltrate really every stage of the AI lifecycle. It often starts right at the beginning, data collection and curation.
Garbage in, garbage out.
Exactly the classic phrase. If your facial recognition system is trained mostly on pictures of lighter-skinned people, it's inevitably going to perform poorly on darker skin tones. Simple as that.
Makes sense.
Or think about a hiring model trained on historical company data. If that data reflects past hiring biases, maybe fewer women were hired for certain roles. Historically, the model learns that pattern and perpetuates it.
So it learns our bad habits.
Precisely. Then there's data labeling. Humans label the data, right?
Sure.
And human annotators prompt their own conscious or unconscious biases.
Ah, okay.
Think about labeling things like unprofessional hairstyles in training data for, say, workplace AI. If that's done inconsistently and disproportionately targets styles common among Black women,
Right.
the model learns a completely flawed and biased association.
Right. Subtleties matter.
They really do. And even during model development and training, what we sometimes call algorithmic bias proper, the design choices themselves can introduce bias, even with seemingly good data.
How so?
Well, if you optimize the model purely for overall accuracy across everyone, you might inadvertently end up favoring performance on the majority group just because there's more data for them. And accuracy for minority groups suffers as a result.
So accuracy isn't always fair.
Exactly, not in that simplistic sense. And finally, even in human feedback and deployment, you can get these pernicious feedback loops.
Feedback loops.
Yeah, imagine a search algorithm that's already subtly biased. It shows certain images for a query. Users click on those images, maybe just because they're the only options presented. The algorithm sees those clicks as positive reinforcement, and boom, the original bias gets stronger.
Vicious cycle.
Totally.
Yeah.
And then there's our own automation bias, our tendency to just blindly trust what the AI says. That lets flawed decisions go unchallenged, especially in critical areas like healthcare or finance.
And here's where it gets particularly tricky and honestly a bit counterintuitive for me sometimes. This leads us to the proxy problem, right? And this flawed idea of fairness through unawareness.
Yes, that's a huge misconception.
You'd think, okay, simple fix, let's just remove sensitive stuff like race or gender from the data and the AI can't be biased about it. But it doesn't work like that, does it?
No, it fundamentally misunderstands how these models operate. AI models are incredibly powerful pattern detection machines.
Right.
They will inevitably find other features in the data, things like zip codes, maybe purchasing habits, even the way people write, or the specific names used on resumes. Things that are highly correlated with those protected attributes you tried to remove.
So they find stand-ins, proxies.
Exactly. The model might not explicitly see the race column, but it learns to discriminate based on that proxy, leading to the exact same harmful outcome.
No.
So what this really means is that genuine bias mitigation has to focus on actively measuring and correcting for disparate outcomes how the AI actually impacts different groups in the real world, regardless of what specific inputs went in. It's about the results.
Focus on the outcome, not just the input, okay?
Precisely. And we've seen this play out in some really striking bias in the wild examples.
Like what?
Well, in recruitment, Amazon famously had to scrap an AI tool they built because it was penalizing resumes that contained the word women's, like women's chess club captain, and it also downgraded graduates from 2 specific all-women's colleges.
Seriously?
Yep. It had learned historical gender bias from past hiring data.
Huh.
In criminal justice, the Compass algorithm, which is used in some U.S. courts to predict reoffending risk,
I've heard of that one.
yeah, was found to incorrectly label black defendants as high risk nearly twice as often as white defendants with similar profiles.
That's deeply concerning.
Absolutely. In finance, remember the controversy around the Apple Card? Accusations that it was giving significantly lower credit limits to women compared to their male spouses, even when the women apparently had higher credit scores.
Right, that caused a stir.
And even with the latest generative AI, we're seeing issues. Image models that overwhelmingly produce pictures of white men when you prompt for CEO or engineer.
Reinforcing stereotypes.
Or models that systematically sexualize images of female users, like some early issues reported with apps like Lensa AI. These aren't just isolated glitches. They show patterns of how deeply entrenched bias can become if we're not actively looking for it and fixing it.
Okay, so that's the problem laid bare, and it's clearly a big one, but how do we actually fix this? Let's pivot to solutions, to this idea of fairness engineering and the sophisticated toolkit of technical interventions people are developing.
The how-to.
Yeah. There's this common misconception, maybe hope, that there's always this inherent, unavoidable trade-off between making AI fair and making it accurate. Is that really true? Or can we be more optimistic?
That's an excellent point to raise because the truth is definitely more nuanced than a simple trade-off. Often, as we discussed, bias comes from poor quality or historically skewed data.
Right, the garbage in part.
Exactly. So when you address that issue, maybe through careful pre-processing techniques, you can often end up with models that are not only fairer, but also more robust and genuinely more accurate overall.
Ah, interesting.
I mean, a model that's only accurate because it perfectly replicated historical biases isn't really accurate in a meaningful, useful sense, is it?
Good point. So fixing bias can actually improve quality.
Often, yes. Now, we generally group the technical bias mitigation techniques into 3 broad families, depending on where in the AI pipeline you apply them.
Okay.
First, there are pre-processing interventions. These are applied to the training data before you even start building the model. The goal here is to remove or reduce bias at its source in the data itself.
Cleaning the data first. Makes sense.
Yep. This includes techniques like resampling. That might mean oversampling underrepresented groups, making more copies of their data, or undersampling overrepresented ones to balance things out,
Okay.
or reweighting, where you assign higher importance, or weights, to data points from disadvantaged groups during the training, so the model pays more attention to getting it right for them.
Got it.
There's also something called learning fair representations, LFR. This is a bit more advanced, but it tries to create new features from the original data, new ways of describing the data points that specifically don't contain information about the sensitive attributes, like race or gender, while still being useful for the main task.
Sort of learning to describe people without relying on those biased proxies.
Exactly, that's the idea. So that's pre-processing.
Okay, what's next?
Second, we have in-processing methodologies. These techniques integrate fairness considerations directly into the model training process itself.
So building fairness in as it learns.
Precisely. One common approach is regularization. Here you add a kind of penalty term to the equation the model is trying to solve. This penalty measures unfairness, so the model is forced to find a solution that's not just accurate, but also minimizes that fairness penalty.
A trade-off managed during training.
Right. Another really interesting one is adversarial debiasing. Imagine you train 2 AI models simultaneously, almost in competition.
Okay.
One model, the predictor, is trying to do its main job, like predict credit risk. The other model, the adversary, is specifically trained to look at the predictor's output and guess the sensitive attribute, like race, based only on that output.
Ah, like a bias detector.
Exactly. The predictor then learns to make predictions that are not only accurate for the task, but also fool the adversary, meaning its predictions don't carry information about the sensitive attribute. It forces the predictor to become fair to beat the adversary.
Wow, that's clever, like an internal fairness auditor.
That's a powerful idea, built right into the training.
Okay, so pre-processing and processing. What's the third?
Finally, there are post-processing adjustments. These are applied after a model has already been trained. They're often useful when you're dealing with a black box model, where you can't easily change the training data or the internal logic.
So you adjust the outputs.
Essentially, yes. Techniques here include things like modifying decision thresholds. Maybe the model outputs a risk score. Instead of using the same cutoff score for everyone, you might apply slightly different thresholds for different demographic groups to achieve a specific fairness goal, like equal opportunity.
Okay.
Or there's calibrated equalized odds. This involves adjusting the model's predicted probabilities to ensure that, for example, the true positive rate, correctly identifying positives, and the false positive rate, incorrectly identifying negatives as positives, are the same across all groups. It means the model makes the same kinds of correct and incorrect classifications for everyone.
So trying to level the playing field after the fact.
That's a good way to think about it.
It's really crucial, though, it sounds like, to emphasize that this isn't like picking one algorithm off a shelf. Bias mitigation seems very much an empirical, iterative process.
Oh, absolutely. There's no single best technique or a magic bullet that works everywhere.
Right.
The effectiveness of any approach is highly dependent on the specific data set you have, the particular type of bias you're seeing, and importantly, the specific definition of fairness you're trying to achieve. Because there are different mathematical ways to define fairness, and sometimes they conflict.
So what works for credit scoring might be totally different for, say, ad targeting or medical diagnosis.
Exactly. It requires constant vigilance, testing, measurement, and adaptation. It's an ongoing engineering challenge.
Which leads nicely into trust. For these AI systems to be truly accepted and integrated responsibly, especially in high-stakes areas, trust is just paramount.
Absolutely critical.
And it feels like that trust has to be earned and actively maintained, not just assumed up front. It seems to rely on these maybe 3 interconnected pillars: transparency, explainability, and continuous validation.
Well put. And when we talk about that transparency pillar, a really crucial development has been explainable AI, or XAI.
Right, XAI. We mentioned it earlier.
Yeah, because many of the most powerful AI models, especially things like deep neural networks, are often called black boxes.
You put data in, get an answer out, but no idea why.
Exactly. The internal decision-making logic is just too complex to follow easily. XAI provides techniques to make that reasoning understandable, at least to some degree.
And that helps with bias how?
Critically, XAI provides the diagnostic lens we need to pinpoint why a model might be biased. It can show you, for instance, that a negative prediction was heavily influenced by a feature that acts as a proxy for a protected group. Like that women's chess club example on a resume, XAI could highlight that specific phrase as contributing negatively.
Ah, so it helps you find the smoking gun.
Precisely. Which allows for much more targeted and effective mitigation strategies. You're not just guessing anymore. Techniques like LIME can help explain individual predictions. Why did this person get denied? By showing which features were most important for that specific case.
Okay.
And other methods like SHE p-values try to calculate the contribution of each feature across many predictions, giving a more global view of what the model relies on.
So making the why visible, and to make that transparency more consistent, more standardized, there's this best practice that's emerged: model cards.
Yes, model cards are becoming incredibly important.
They're kind of like a nutrition label for an algorithm. Is that a fair analogy?
That's a great analogy. They're basically structured documents that accompany a trained AI model. They provide standardized, hopefully accessible information about its intended use, how well it performs, including for different groups, its known limitations, and the ethical considerations that went into it.
Okay, standardized info.
And what's particularly powerful about model cards, I think, is that while they're great for external transparency, telling users what's going on, their biggest impact might actually be internal within the organization developing the AI.
How so?
Well, the very process of creating a model card acts as a powerful forcing function for ethical rigor.
A forcing function.
Yeah, it forces developers and teams to actually confront difficult questions before a model gets released. Questions like, how does this model perform not just overall, but for specific intersectional groups, say, older women of a particular ethnicity? What are the potential ethical risks if this model is used in a way we didn't intend? What steps did we actually take to mitigate known biases?
So it makes them document their due diligence.
Exactly. It formalizes that ethical due diligence, making sure these considerations are addressed throughout the life cycle. It really helps operationalize that shift-left principle we talked about earlier.
Got it. And key parts would be things like showing performance across different groups and maybe warning about uses it wasn't designed for.
Absolutely. That disaggregated performance analysis is key, showing the results broken down by demographic groups. And detailing out-of-scope uses is crucial to prevent misuse.
And as you said, trust isn't a one-time thing. You launch the model, you put out the model card, but that's not the end, right? There's this imperative of continuous validation.
Absolutely not the end.
Yeah.
A model that's fair and accurate today might drift tomorrow.
Drift.
Yeah, the real world changes. the data the model sees in production starts to look different from the data it was trained on. This is called data drift, and it can cause model performance to degrade significantly, and new biases can emerge over time.
So you have to keep checking.
Constantly. That means vital practices like monitoring for model and data drift are essential. You need systems in place to detect these changes and trigger retraining or adjustments when needed.
Okay.
You also need regular auditing for bias and compliance. Proactively, systematically searching for emerging biases and making sure the system continues to meet ethical standards and any relevant regulations.
Ongoing audits.
And finally, especially for critical decisions, think healthcare, major financial decisions, justice. Human in the loop, HITL, oversight remains absolutely essential.
The human backstop.
Exactly. It means a qualified human expert retains the ultimate authority. They review the AI's recommendations, they can override them if necessary, and crucially, they take final responsibility for the decision. It's about AI augmenting human capabilities, not replacing human judgment or accountability.
That makes perfect sense. So with all these technical tools, transparency measures like model cards, continuous monitoring, what does this mean for how organizations actually structure themselves for this? Beyond the algorithms, what broader structures are needed for real accountability?
That's a critical question.
We hear this term, a shared but delineated accountability supply chain. What does that look like in practice?
Yeah, that concept reflects the reality that AI isn't usually built and deployed by just one entity. Responsibility needs to be assigned clearly to different actors based on their role in that chain. You might have the providers, maybe big tech companies creating powerful foundation models. Then you have integrators who take those models and fine-tune them for specific industries or applications. And finally, the deployers, the organizations that actually use the AI system in a specific context with end users, like a hospital using a diagnostic tool or a bank using a credit scoring model.
So everyone has a piece of the responsibility.
Exactly. Each has distinct obligations because bias or risk can be introduced or amplified at each stage. And a really critical evolution here, something making this more manageable for organizations, is reframing ethical AI through the lens of risk management.
Treating it like other business risks.
Precisely. Abstract ethical concerns, fairness, bias, privacy, are translated into concrete categories of risk. Things like risk to fundamental rights, safety risks, financial risks, reputational risks. And once they're framed as risks, they can be governed using familiar enterprise risk management, ERM functions.
Like risk assessments, audits, internal controls, stuff businesses already do.
Exactly. This is how we move ethics from being a purely philosophical debate into becoming a core business discipline that can be managed systematically, governed at scale, and integrated into existing processes.
Yeah.
It makes it actionable.
And alongside these internal structures, we're seeing key regulatory and standards-based frameworks emerge to shape this landscape, sometimes with pretty different approaches.
Yes, the external landscape is evolving rapidly.
In the U.S., for instance, we have the NIST AI Risk Management Framework. My understanding is that's a voluntary framework.
Correct. It provides a flexible, structured process for organizations to manage AI risks. It revolves around functions like govern, map, measure, and manage. It's designed to be adaptable across different sectors and use cases.
Okay, voluntary and flexible. Then, in pretty stark contrast, you have the EU AI Act.
Yes, a very different beast. That's a landmark, legally binding regulation.
Binding. Okay.
It takes a strict, risk-based approach, categorizing AI systems based on their potential for harm. Unacceptable risk systems are banned. High-risk systems face very stringent requirements. Then limited risk and minimal risk.
And high-risk systems, they have tough rules, like transparency, data quality, human oversight.
Extremely tough requirements.
Okay.
And crucially, there are severe financial penalties for non-compliance. It has real teeth.
Right. And then there are also professional standards, like the IE 7000 series.
Exactly. These are standards developed by engineers for engineers, promoting ethics by design. The idea is to embed ethical considerations directly into the engineering and system design processes from the ground up. IE even offers a certification program called Certify to verify that systems meet these ethical design standards.
So we've got voluntary guidelines, binding law, and professional engineering standards all sort of converging on this problem.
That's right. It's a multi-pronged approach.
And how are the big tech companies, the ones often building these foundational models, how are they operationalizing these principles? Any quick examples?
Yeah, briefly, most major players have published their own sets of AI principles. Microsoft, for example, talks about 6 core principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. and they offer tools for developers like the Responsible AI Dashboard in Azure.
Okay.
IBM highlights 5 pillars of trust: explainability, fairness, robustness, transparency, and privacy. And they're particularly noted for contributing open-source toolkits like AI Fairness 360 and AI Explainability 360, which are widely used by researchers and practitioners.
Right. Those toolkits are popular.
And Google, of course, has its 7 AI principles. And as we mentioned, they pioneered the model cards concept as a way to increase transparency.
So similar themes, different implementations.
Exactly. And what's really important to remember is that while these underlying principles, fairness, transparency, accountability, are becoming fairly universal, their specific application is highly context-dependent. Well, the priorities and specific risks look different across industries. In healthcare, the paramount concerns might be patient safety, data privacy under regulations like HIPAA, and ensuring equitable access to care. In the financial sector, the focus might be more squarely on fair lending laws, preventing discriminatory credit scoring, and ensuring algorithmic trading systems are stable and don't pose systemic risks. The principles are the same, but the implementation has to be tailored.
That makes sense. Context matters hugely. So, bringing it all together then, our deep dive today has really charted this journey of ethical AI, moving from, high-level ideals to very practical operational challenges and solutions.
It's been quite an evolution.
We've talked about that critical shift left imperative, getting ethics in early. We've hit on the definitive failure of just ignoring sensitive data, that fairness through unawareness idea,
Yeah.
and why we need to focus instead on actively measuring and correcting disparate outcomes.
Outcomes are key.
And understanding bias not as these isolated mistakes, but as a systemic failure that needs systemic solutions, technical, organizational, and regulatory. It feels like we're moving beyond just talking about it to actually engineering it.
That's exactly right. And this truly is an ongoing challenge. It demands sustained collaboration across policymakers creating the rules, industry building the tech, and the research community pushing the boundaries of what's possible in fairness and transparency.
It's a group effort.
Absolutely. The path forward really requires moving beyond just the philosophical debates, valuable as they are, and toward the disciplined engineering of trustworthy AI systems. It's complex, it's definitely iterative, there will be setbacks, but it's absolutely essential for the future we want AI to help build.
Couldn't agree more. And understanding ethical AI for everyone listening isn't just about avoiding harm, though that's critical. It's also about unlocking a future where AI genuinely serves humanity, where it augments our capabilities in positive ways, and maybe helps foster a more equitable society for all.
That's the ultimate goal.
So a final thought for you, our listener. As you interact with AI every single day, whether it's your search engine, your streaming recommendations, your smart assistant, how might you start demanding more transparency and accountability? How can you be more aware?
Good question to ponder.
We really encourage you to continue your own deep dive into this vital topic. Maybe next time you use an AI tool, see if you can find a model card for it. Or just take a moment to reflect on how data bias might be subtly shaping the digital world around you. The information you see, the choices presented to you, it's something we all need to be thinking about.